Alright guys, Mega Review Day 3, Part 2. Number 6, density is calculated as D is equal to mass over volume. What is the density of 0.28 moles of helium gas that is held at 1.12 liters? So first thing we got to look at here is density is mass over volume. We have a volume, but this is not a mass. The only way we can measure mass is in grams. Density actually has a unit of grams per liter. So we just have to take one extra step here before we divide and calculate what this is in grams. So we have 0.28 moles of helium, and we want to convert that into grams of helium. Well, moles gets a 1, and grams is going to be the molar mass of helium here. So helium, we got 4.0026. We're just going to leave that as 4 grams of helium. So we multiply that out, we get 1.12 grams of helium. So now we have our mass. That might not actually be exactly 1.12. Let's go ahead and type that in just to be sure. So 4 times 0.28. Okay, so 1.12 grams of helium. And now we're going to divide that by 1.12 liters. It gives us a nice even 1 gram per liter. That's our final answer. Number 7, more vocabulary. Water is an absolute necessity for functioning life. Our blood, which is 83% water, carries potassium and sodium ions. That's super important there. To the heart. What is the property of water that allows this to happen? Well, ions have charges. The reason water can carry it is it can interact with those charges. What's the property of water? It's polarity. What's the most important thing that we know about water is it's polar. Number 8. How many milliliters of solution can be made from 45.75 grams of potassium chlorate if you need a solution with 2.55 molar concentration? Well, nothing's changing here, so we know that we're going to have M is equal to number of moles over liters. Problem is, we don't have moles, we have grams, so let's get to convert. 45.75 grams of potassium chlorate, polyatomic there, KClO3. We want to get that to moles of KClO3 from grams. We need to add up the masses of all of our elements. So we have potassium is 39.10 plus chlorine 35.45 right here. And then we have oxygen, which is 16, but 3 times. So we end up with a mass of 122.55 grams of KClO3. Multiply across, divide down, 45.75 divided by 122.55 gives us 0.373 moles of KClO3. Now that we have this, we can plug it into the equation. So, thing is, now we have moles and we have our molarity. We're trying to solve for liters. So we rewrite the equation. 2.55 m is equal to 0.373 moles over liters. So we have to put this over 1, and then we're going to cross multiply. So we're going to end up with 0.373 times 1 divided by 2.55. So just 0.373 divided by 2.55, and we get 0.146. Now that's in liters. The question, though, is asking for milliliters, so we're going to convert that one more time by multiplying by 1,000. So we get 146 milliliters. Number 9. 500 milliliters of a 0.25 molar aluminum nitrate is mixed with excess sodium hydroxide. And I've just realized I didn't have that on for that. Oops. So here's all our work left from that one. We converted grams to moles. We got the 0.373, and then we plugged it in the problem. 0.373 times 1 divided by 2.55 when we cross multiply. We got 0.146. Converted that to milliliters. Sorry about that, guys. All right, number 9. 500 milliliters of 0.25 molar aluminum nitrate is mixed with excess sodium hydroxide. How many grams of aluminum hydroxide will be made? So the first thing we see there is excess sodium hydroxide, so we're not too worried about that. But we do need to go ahead and write an equation because it's asking about one of the products. This is essentially just a stoich problem, but it's including concentrations now. So start off with the equation. Aluminum nitrate. Aluminum is a +3 charge. Nitrate is a -1 charge, so we need 3 of them. Sodium and hydroxide cancel out. Trade partners. Aluminum goes with hydroxide. Sodium with nitrate. And we'll have to go ahead and balance here. So put a 3 for the hydroxide. We need 3 here. And that should be everything. So this will be 1 and 1. So how many grams of aluminum hydroxide will be made if we have this much of our aluminum nitrate? So this one's a little bit different because we don't really have an amount for this one. We have the volume and we have the concentration. But what we need so we can actually do our train track is to find out how many moles this is, which we can do with those two things. So let's go ahead and get this to moles first. So we have M is equal to moles over liters, which we rewrite as 0.25 M is equal to moles over liters. All we have to really do in this situation is multiply whatever liters we have, which is 0.5 because we had 500 milliliters. 0.5 times 0.25 gives us about 0.125 moles. Sorry how crowded this is. All right, so 0.125 moles of AlNO3, 3. And we want to take that to grams of aluminum hydroxide. So we're at moles. We can go from moles to moles. So this will be moles of AlOH3. And we finally want that at grams AlOH3. Bring down your units. And we can start to fill in. So moles over moles, we've got to look at the coefficients here. So we have 1 for AlNO3, and we have 1 for AlOH3, so we're fine there. Need to know the molar mass for aluminum hydroxide. So aluminum, we're going to take a look at. Aluminum has 26.98, and we have one of those. Plus oxygen, we have 3 of, because of this subscript here. So 16 times 3 plus 3 hydrogen. Just going to add 3.03 there. Mass for aluminum hydroxide is 78.01 grams, which we then multiply times our 0.125. Gives us a final answer of 9.75 grams of aluminum hydroxide. You're very squished in there. All right, last one on this page. Number 10, calcium carbonate decomposes into calcium oxide and carbon dioxide. What is the volume of CO2 that forms from 5 grams of calcium carbonate at 1.25 atmospheres in 25 degrees Celsius? So this is actually a big mashup problem here. We've got some stoic going on, and we've also got some gas laws. So there's a couple of ways that we could do this. I find the easiest is using Pivnert. PV equals nRT. So the problem is we have pressure, we have temperature. They're asking for volume, but we have grams of a different product instead of moles. So they are asking about CO2, but they're giving us grams of CaCO3. So what we need to do is a stoic problem so we can find how many moles of the thing in question. So we're going to start off by writing the actual balanced equation. Calcium carbonate plus 2 minus 2 decomposes into calcium oxide plus 2 negative 2 in CO2. Check our balancing here. We've got good. That's 1 carbon, 1 calcium, 3 oxygen, 3 oxygen. So we're good at that point. So all of these get a 1. So we're going to go from grams of this to moles of this. It's going to be a grams to moles to moles. Grams of CaCO3. That was 5.25. Moles of CaCO3. moles of CO2. Bring down your units. Moles over moles, all of our coefficients are 1. This mole is also going to be 1. So now we need to look at calcium carbonate. Calcium, we've got 40.08 plus carbon 12.01 plus oxygen times 3, so 16 times 3 gives us a total mass of 100.09 grams. Multiply across, divide down, 5.25 divided by 100.09 gives us 0.0525 moles of CO2. Now that's only half the question, so now we have to actually plug that into Pivnert. But we now have moles that we can plug in. So Pivnert, pressure we're given 1.25. Volume is what we're looking for, equals 0.0525 for our moles. Our pressure is in atmosphere, so R is going to be 0.0821 times temperature. So temperature here is at 25 degrees Celsius. We can't have it in Celsius. We're going to add 273 to that, which is going to give us 298 Kelvin. Get rid of the pressure. Now all we have to do is really type that in. So 1.25 divided from the top, 0.0525 times 0.0821 times 298 divided by 1.25. Our final volume comes out to 1.03 liters, because volume is always in liters for our ideal gas laws. So that was a tough one, but that is it now for page 2. See you in the last video.